This is MEI Statistics Minor, Discrete Random Variables 1, Mean and Expectation, 1.3, Mean and Variance of the Uniform Distribution. So sometimes it's possible to derive general results which we can then quote subsequently. One example of one of the distributions we've already met is the discrete uniform distribution. And just to remind you, each of a finite number of values has equal probability. So the standard uniform distribution, the one that you'll encounter, has values 1, 2, 3, all the way up to n, and the probability of each is exactly the same. So if there are n values, the probability of getting each will be 1 over n. So if all the probabilities are 1 over n, then the value of xp in each case will be 1 over n, 2 over n, 3 over n, all the way up to n over n. And similarly, the values of x squared p will be 1 over n, 2 squared over n, 3 squared over n, all the way up to n squared over n. So if we wanted to calculate the expected value of x, we know that that is the sum of all the x's times the probability that x is x. So in this case, that is going to be the sum of x times 1 over n. Now that 1 over n, that is independent of the sum, because our sum will be going from x equals 1 up to n. So we can take that outside, and we'll get 1 over n times the sum from x equals 1 up to n of x. Now you might recognise that as the triangle numbers. That's 1 plus 2 plus 3 plus 4 all the way up to n. So you may well know that the formula for that is a half n times n plus 1. You can also do the same with an arithmetic series formula. So our 1 over n and our n will cancel out, so we will get half times n plus 1. That is our expected value. If we want to do the variance, we remember that that is the expected value of x squared minus the expected value of x squared. So first things first, we're going to need to calculate the expected value of x squared. Well, that is going to be similarly the sum from x equals 1 up to n of x squared times 1 over n. Again, that n is independent of the value of x. So it's 1 over n times the sum of x equals 1 up to n of x squared. And that's another standard formula that is in the formula book, the sum of the squares. And that is equal to, so that would be 1 over n times 1/6 n plus 1 to the 1 over n, and the n will cancel out, so we get 1/6 n plus 1 to n plus 1. So as I said, the variance of x is the expected value of x squared minus the expected value of x squared. So that is going to be 1/6 n plus 1 times 2n plus 1 minus 1/2 n plus 1 all squared. Now when I square this fraction at the end, I'm going to get a quarter. I'm going to want the same denominator throughout, so I'm going to put everything over 12. So it's 2 over 12 times n plus 1 2n plus 1 minus 3 over 12 n plus 1 squared. We can see there's a factor of n plus 1 in both of the terms, so I'm going to take that out as a factor as well and just leave 1/12 on the outside. So 1/12 n plus 1 times 2 lots of 2n plus 1 minus 3 lots of n plus 1. So that's 1/12 n plus 1 times 2 lots of 2n minus 3n. is an n. 2 lots of 1 minus 3 lots of 1 is a minus 1. And so that's going to be 1/12. Difference of two squares tells me that's half n squared minus 1. So there are the results. Those are both in the formula book. Okay, so unless you are asked to prove them, you can use those results straight off. So if we get a simple question like this, work out the mean, variance and standard deviation of the score when rolling out a fair 8-sided dice. So we know we have a uniform distribution because it is fair, and it has 8 possibilities from 1 up to 8. So if n is 8, then the expected value of x is going to be a half times n plus 1, 8 plus 1, which is 4.5. The variance of x, remind ourselves that that is 1/12 n squared minus 1. So that is going to be 1/12 times 8 squared minus 1, which is 5.25. The standard deviation, which we normally write as sigma, is simply the square root of the variance, which is 2.29 to 3 significant figures. In the next video, we are going to be looking at expectation of variance of a plus bx, where a and b are constants.